Okay, so if you had any issues with the login to the ChemFORWARD platform, Gabby will go through that here in just a minute. One last thing before we really get moving. There will be up to 20 classrooms that will be provided free access to the ChemFORWARD platform for this fall. So the information here on how to request that access will be in the slide deck. And if you do get access, one of the things that will be useful for us is at the end of the semester to get feedback from everyone who uses the platform during the fall semester. I will be using it, Cynthia will be using it, and others will be using it, and we would like as much feedback as possible so we can make any minor revisions in that and improvements as needed and answer any questions throughout the fall semester that you may have. So I will show this again at the end of the slide deck. Okay, so let's go through and give just a quick overview, and then we'll turn it over to Gabby to talk about the details of the ChemFORWARD platform. So this module is based loosely on green chemistry principle number 4, designing and then also using safer chemicals. And one of the problems I know in my green chemistry course here at the University of Toledo, we cover chemical hazard assessment, risk, hazard. We talk about choosing safer solvents, but it's not always easy to find resources where students can go and actually find chemical hazard information and real data to choose safer chemicals or safer solvents or safer ingredients for a formulation. So this is what the ChemFORWARD platform allows students to do quite readily, and it's very easy to use. If you've looked through the material, the hazard band rating is shown here, and Gabby will give more information. But on the left, you see it goes from A to question mark. Chemicals that are given an A or B hazard band rating are safer chemicals for use. Those that are rated as C are usable, right? But you can always look for something better. D and F should be avoided. And then U would be given to chemicals that have had a chemical hazard assessment that have excessive data gaps. And then if there's no chemical hazard assessment performed and very little data, the chemical is given a question mark. And the chemical rating off to the right column, if you have questions on how those hazard bands are determined, Gabby would be best suited to explain that. So the module is organized into 2 main units, and then unit 0 is really background information. So if you haven't done so already, what you'll find in unit 0 is background information on risk and hazard, and the difference between risk assessment, hazard assessment, and chemical alternatives assessment. There are also some links and other reference materials that you can use to supplement this material. Unit 1 is really the bulk of the module. This is how to use the ChemFORWARD platform, what kind of information you can obtain using ChemFORWARD, and how you and students can use the ChemFORWARD platform to find safer chemicals or safer chemical ingredients. Unit 2 is a smaller unit, and it focuses on 2 things: avoiding regrettable substitutions based on real hazard data, and stressing to students that just because something is natural doesn't mean that it's always safer, okay? And that's a big concern today with all of the marketing that we're bombarded with. So each module comes with a unit overview, a list of learning outcomes, course alignment, some suggested prerequisites, PowerPoint slides, and then either assessment or review questions that could be PowerPoint format or Word document. And then there's some overall instructor's notes. Unit 1 also has a detailed how-to guide for ChemFORWARD. So there's more information in the how-to guide than what is in the slide deck that Gabby's going to go through. And then there are 5 assignments that are related to Unit 1 that can be used in a variety of courses ranging from Gen Chem, organic, cosmetic science, green chemistry, inorganic, maybe chemical engineering, etc. Unit 2 has one assignment, and it's focused on the safety of botanicals and essential oils. So that would be great for a cosmetic science course, for instance. Learning objectives are shown here, so I won't go through them in detail. They are in the materials that are available for download. Now, for the Unit 1 assignments, we will go through some of these during the workshop, but I just want to show you an example or two that we might not get to. So for instance, there's a safer deodorant ingredients assignment where quite a number of ingredients in a commercial deodorant, which we shall not name, are listed, and we request that the students use the ChemFORWARD platform to determine the hazard band for the ingredients, what the important hazards are for each ingredient, and then possible alternatives using the function option or the function pathway in the ChemFORWARD platform. So a student may submit answers in an answer key as shown here, where the chemicals, let's see, it seems like I skipped one. Nope. Oh, that is the key, sorry. Yeah, so here the hazard band is listed with the hazards, and then potential alternatives are shown off to the right. Now, these are not necessarily the only potential alternatives, but these are some that the students may select. Another assignment would be silicon-containing ingredients in cosmetics and beauty products, focused on some polymeric siloxanes and cyclic siloxanes. And what you see here is that the small cyclic siloxanes have very poor hazard bands. They're rated F, and the reasons why are off to the right. And depending on the course you're teaching, you may be interested in having students search the structures of those compounds, so they're familiar with the structures. And these are the structures for some of those compounds, and this is provided in the answer key to the assignment. Now for Unit 2, regrettable substitutions and naturally occurring chemicals, what you find are slides that include the definition of a regrettable substitution and why we would want to avoid a regrettable substitution. And the main point at the bottoms of the slide is that when picking a safer chemical, we want to make that decision based on real, reliable hazard data so that we make that substitution safely and we don't make a mistake and end up with a chemical that is as bad or worse than the one that we originally intended to replace. Now, in the module, we give 3 main examples. You may be familiar with these. These are common examples. But microwave popcorn, the one chemical that causes what is called popcorn lung, was replaced with a chemical that only had a difference of 1 methyl group. It ended up having the same problem, not surprisingly. The brake cleaner example, where chlorinated organic solvent was replaced with hexane, and the hexane, of course, was later found to be metabolized in the body to a neurotoxin, right? So a regrettable substitution. And then you've all heard about bisphenol A. Well, people replaced bisphenol A with derivatives bisphenol S and bisphenol F, which have the same problems as bisphenol A, right? So the problems weren't solved. But there's more details in the slide deck. So the upshot is, for students, is something safe just because it's natural? And of course, the answer is no. Regardless if something is synthetic or naturally occurring, it's better to base ingredients and formulations on real hazard data to pick safer chemicals. So there's more information in the slide deck on this. One of the examples given are plants. A high percentage of the plants on the planet are toxic to humans. Just a few examples are given here, and there's reference materials. You can get more information in the module. Here's a nice example if someone wants to go into more detail, for instance, using foxglove, which I actually have in my gardens at home. So sassafras is another great example. Sassafras, the main component at the bottom there is safrole, 85%. Camphor and methyl eugenol, 3% and 1%. And this, of course, used to be used in root beer with natural flavorings. And you can still go online and buy sassafras extracts from Etsy and all kinds of places. Some of them are safrole free, and not a lot of them say that they're safrole free. If you had a chance to look at the pre-workshop assignment and looked up the ChemFORWARD hazard band for these three chemicals, what you find is safrole has a hazard band of F, as does the methyl eugenol. And safrole is a known carcinogen. In fact, it was banned from use as a food additive in 1960, so a long time ago. So again, a great example of a naturally occurring substance that's not safe for consumption. So anyway, so that's a really quick overview to give you an idea of what's covered in the module in case you haven't had much time to look at the module. Let me go ahead and turn it over to Gabby so that she can go through the details of the ChemFORWARD platform and how to use the ChemFORWARD platform. And Gabby, let me stop sharing so you can share your slides.
Great. Thanks so much for the introduction, Mark. I am going to turn my camera off while I do this presentation, just because the full caveat, I do not have power right now, so I'm hotspotting with my phone. And if I do get shaky, just please let me know in the chat. All right.
I'm sorry, I have a quick question before you start, Gabby, and it was to Mark.
Yes.
Do you guys have you taken a look at some of the things that have been on like Instagram and TikTok, like all of these things talking about creating detergents that are natural chemicals, get chemicals out of your. So I'm just wondering, you know, pointing kids to these kinds of things too. Do you know what I'm saying? Just kind of like another idea. But I love the sassafras example. That's awesome. That's awesome.
I am not on TikTok.
I'm not either. I do Facebook and Instagram, and that's it.
But what I will say is we have family friends who are sort of homesteaders, and they like to make a lot of home remedies and their own, cosmetic personal care items. And I know they, how do I put this? They make some of their own formulas that I don't consider safe, but they consider them to be because they're all natural.
Natural. Yeah. Okay.
Yes. So anyway, I'll just leave it at that and turn it over to Gabby.
Okay. Thanks.
Great. That's a great answer, Mark. So instead of going through slides, what I'm going to do is take you all through a demo of the platform. And I'll first just give a really brief introduction to ChemFORWARD. This is our website landing page. As I briefly mentioned in my intro, we are an independent science-based nonprofit organization. We're an independent project off of Healthy Building Network, which is now and what we do is we offer these are chemical hazard assessments. And what the goal of those is to do is to provide users with really consistent and reliable toxicology information on chemical alternatives. This is a first of its kind repository, and it operates on a cost and benefit sharing model. And it allows users to identify and eliminate chemicals of concern, avoid regrettable substitutions, such as Mark touched on in the intro, and design safer products from the beginning. Historically, this system of private CHAs has been really high cost and subject to inconsistencies. So what the goal of ChemFORWARD is to do is to raise all these boats towards this shared goal where they're all housed here. And that just makes it so that it's not a competition, it's not inaccessible. Everything is housed in one place. So I will tab over to here. This is where I've logged in. And you'll notice that this says beauty and personal care. So this means that I'm logged into our beauty and personal care vertical. We do have other verticals, such as for consumer electronics. We have one for plastic additives. So we're using the beauty personal care vertical today. This is probably our best built out vertical, just because as you guys know, and when you look on the back of your shampoo bottle, beauty personal care ingredients are fairly transparent. It is really easy to get that information as to what is in our products. So this is one of the reasons that we use this as our example here. So we land here. This is a broad overview, what we can do with this platform. We have some news items down here, some newly added chemicals. If we scroll down, but what's really most interesting is this left-hand side and the search bar up on top here. So we'll first go through a couple of these options on the left-hand search bar. The first one being function. We click into here. We have different tagged functions for each of the chemicals that are in this repository. Some ones of interest may be like antioxidants, antimicrobials, antifungals, and the list goes on. So this is an ongoing tagging project that we do have within this beauty personal care vertical. Again, if we were to go to our electronics or consumer electronics vertical, these functions would be specific to the types of chemicals that are used in that industry. I go to applications, pretty similar, but we see some broader actual product categories that chemicals are tagged into here. For example, like moisturizers versus oral care, those aren't the actual function of the chemical, but they're ones in which they are applied and the types of products that they're applied. And that allows us to, for example, if we wanted to look at hair care, but then also, and this might not, maybe a little slow again because of my internet issues right now, but I could select for hair care and then a function within that application. The next one on this list are chemical classes. So these are the types of chemicals that we could also then search by. If I tap down to safer alternatives, this is all right, except I'm a little frozen. 1 minute. There we go. If I select for safer alternatives, what this will give me is anything that ChemFORWARD considers to be a safer chemical. And this means anything that is an A hazard band, a B hazard band, or a C hazard band. So if I wanted to find some sort of alternative to a phthalate, fragrance solvent, or fixative, I could select for that. And you can see that we only have Bs and Cs in this list. Further on down this list, have US EPA safer choice ingredient list chemicals. These are the different scores that they use. So if I wanted to make sure that something was a certified green circle on the skill listing from the EPA, this is where I could find those ingredients. And you'll see that I still have one of those active search filters on here. So these are full green circle skill chemicals that are also tagged to this safer alternative to phthalate, fragrance, solvents, and fixatives category. So I can also deselect for that. Right, while that loads, you'll note that this last one here is safer trade names. And this is part of our effort to not only include CAS-specific CHAs, but we also offer a repository of trade name ingredients that manufacturers can submit their products to. So we have a couple here from Angus, Canova, Dow, Analux is one that we have quite a bit from. Let me deselect for skill. But what this does is it offers manufacturers the option to either disclose all of their contents of our particular trade name ingredient, or redact some of those. So this isn't a great example because this is approximately 100% this one cast number. But if I go back and find one with a little bit, couple more, let's try SpectraStat. And see here that this page on the contents offers information about the concentrations of specific chemicals that comprise that trade name ingredient, as well as the individual ingredient level hazard bands of each of those. So again, this isn't that interesting an example because all of the chemical names are disclosed here, but as we know with trade name ingredients, sometimes not all of those ingredients will be disclosed. So this offers manufacturers an option to redact some of those chemical identities and still present the hazard band for them so that the manufacturer or a designer of a product can say, okay, I don't know what it is, but I know that it's safe. And that is just our effort to help protect CBI while still making sure that we know that we're using safer ingredients in whatever product that we're trying to design. So these are the left-hand search bars. Another way that a user can go about this journey is using the search bar on top. An example here, I think one of the ones that we consistently use is diethyl phthalate. So this is a landing page for a chemical that does not yet have a hazard band. What you'll see here is that we have a summary of the overall chemical. If we tab over to hazards, this is more or less filled out, but when I show you a full CHA hazard table, you'll note the difference here. These specific hazard endpoint levels or scores are being funneled in from our Pharos API. So we have a lot of information on certain lists that this chemical is on pursuant to each of these specific hazard endpoints, but doesn't give us enough information to give this roundup hazard band. So this will be a little bit different when I go to an actual full CHA chemical, and I'll give that comparison there. But if we do go to identifiers, all of this will be the same. We have some potential synonyms, alternative names, INCI names, PubChem CIDs, properties as are also available through our Pharos API, functions and tags. This is what is informing this left-hand search function here. Regulatory lists, as well as non-regulatory lists. So say I wanted to find something that was an actual hazard banded chemical for my particular use case, that being, for example, a fragrance solvent or fixative. I can go into these cast level search and say, I think that this one is of interest. I can click on triethyl citrate. And what you'll see here is that there actually is a chemical hazard assessment available for this one. The date and who assessed this chemical is also available on the right-hand side. And similar to that chemical that did have the had a profile, but only at a question mark hazard band, we have the overall summary. We have the chemical rating, which is associated with one of our hazard bands. These are all detailed here. This is a gray C chemical, which when I tab into the hazard table, I can give a more detailed explanation as to what this means. But this just means that there is a data gap that exists for one of those endpoints. And because we do not want to conflate lack of data with lack of harm, we consider this to be like a moderate hazard. We call this gray C, which is a C hazard band. This has all the same similar properties and identifiers, except because this is a full CHA, all of these are actually curated by our assessor, which completed this chemical hazard assessment. So all of this has been specifically sought out by the assessor group and then also peer reviewed by a verifier. And this often is a really iterative process where they go back and forth, making sure that everything is verified and completely correct and is highly curated. And that also goes for the functions and tags and regulatory lists. So interesting part here is the hazard table. And Monica, please just give me a sign if I'm going over time because I do not have my eye on the clock. But this is the GHS hazard table. And you'll note that there's two up here. There's both GHS and cradle to cradle. This is because we base all of our hazard methodologies are based on GHS, similar to cradle to cradle. Also uses GHS methodologies in their chemical hazard assessment methods. But we offer two tables here. This first being GHS. This offers the user guidance on how to read the summary table. And what the user can do is click through each of these particular endpoints, many of which are stratified by exposure route, such as carcinogenicity, reproductive toxicity, and they can click on this to get a really brief rationale as to why the assessor and verifier have arrived at the classification that they did. So all of these that are in the GHS table, these are all based on GHS, the classifications for each of those endpoints. So not classified, meaning that there's no data, confidence is low because there's only one study available, but this does align with their not classified criteria. Category 3 for STOT neurotoxicity, single exposure means that means the criteria in the GHS document. We do go to cradle to cradle. This is all based on the cradle to cradle material health assessment methodology. So that you'll note that this is a little bit extended. This has more hazard endpoints than what's available on GHS, such as endocrine activity. So for example, if I click here, even though this is gray, this is still clickable on this table and is not located on this GHS table. Our scoring for each chemical is based on the cradle to cradle table. So you'll note that we have no data for reproductive and developmental toxicity and no data for endocrine. We have no data for neurotox. And this is overall what's driving this gray C chemical hazard score, which again is associated with the C hazard band. Does anyone have any questions or want me to click into any of these rationales that they think is maybe of particular interest?
Heather, 2 minutes. Thank you.
Great.
I have a question. Can you please go over how we can find the safer alternative for any of these?
Sure. So we actually consider anything to be a C or hazard band or above to be a safer chemical. If, for an example, if you did want something that had a higher hazard band, meaning that it didn't have a gray or any sort of data gap in its hazard profile, what we could do is go back to functions. I believe I had selected for fragrance, solvent, or fixative. We could go back to functions here. And what we would be directed to is a list of 4 additional chemicals that fall under that active search filter. that have a B hazard band, meaning that there is no data gaps for any of those criteria endpoints. So, and by criteria endpoints, I mean there is, so this one, for example, has a data gap for terrestrial toxicity, but our scoring and the way that cradle to cradle scoring is written is that terrestrial toxicity is essentially not factored into the overall score. But for all of these other priority human health criteria, all of these do have a score. So this is green across the board. Here it says yellow for oral tox, would be yellow for neurotox, as well as respiratory, skin, eye, corrosion, irritation, and sensitization. But this would be substantially a better or safer option relative to the one that we were just looking at previously, because it did not have a data gap. Does that answer your question, or would you like to look at another example?
Thank you. No, I got my answer.
Wonderful.
Yeah, thank you, Gabby. I think
Great.
when we do more exercises with the module, it might answer some of the questions.
Perfect. Great.
Great, thank you, Gabby. So I think next on the schedule was Cynthia was going to discuss the pre-workshop assignments.
Okay.
And I think that was the pet shampoo assignment, and answer any questions on that. I'll turn it over to Cynthia.
Okay. I am looking in, well, let's share my screen. Let's start with that. Okay. Uh-huh. You can see this screen. That's not what I'm looking for. How about that? Okay, so the pet shampoo assignment, I just pulled up one of the submissions. I've moved away from the person's name. Okay, so this pet shampoo is based on a commercially available product. We're not going to name it. Okay, but it is, it has a very short label. Okay, there are not that many ingredients in it. So that's why we chose this for this particular assignment. Okay, and basically some questions about using a pet shampoo. Okay, and then the 4 main ingredients were chosen. And I'm just going to ask a silly question because it's just been that kind of day. Can you see my screen?
Yes.
Yes.
Excellent, thank you. So students would look up these chemicals. You as the student would look up these chemicals, identify the hazard band. And this manufacturer has, for this particular formulation, the hazard bands are all A and B, which is fantastic. Okay, so this part sort of, as a student, maybe isn't so interesting. Okay. The interesting part comes, we've got 1 C in there. Okay. The interesting part comes with the other ingredients that they say there's preservatives and pH adjusters and fragrances in there. And the manufacturer is kind enough to share some information about what they used. And now these are the interesting part. These are less ideal. Okay, relatively safe, but they're not fantastic. Okay. So this would lead students, or you as the faculty working through this, to make a decision about, is this particular product safe? And there could be a diversity of opinion. I have had students in my classes say, if it's not an A, I don't want to use it on my pet. Okay, fair. It's a fair answer. But it brings up some dialogue to say, okay, is there a preservative in ChemFORWARD that is an A? and let them look at that. And if there isn't, then you say, okay, well, maybe the best we could do is a B. Now, how do you feel about it being safer? Okay. So in this particular assignment, this question 5 is, in my opinion, this is the discussion point. This is where you're going to have lots of diversity of opinion on this. Okay. So I'm hoping that is my 2 to 3 minute once over the world. What are questions I can answer for you about this particular assignment or pieces in this assignment? And I
have a
will say,
question.
while I'm looking at my screen, I can't see the chat.
Yeah, I have a question. I'm wondering, why should they use benzoic acid and trisodium phosphate as pH adjusters? And there are so many other common things are available to adjust the pH.
I don't specifically know why the manufacturer used those,
I'm
to be
guessing
honest with you.
I'm guessing cost or supply.
That could be very well.
Probably. But I love that I can imagine the type of discussions that this will bring forward. And also, again, to talk about rate of exposure. I mean, how often are you bathing your pet? For how long? What's the amount of the stuff that you're using? Like, these are all things that are rational types of dialogue that the general public may not be thinking about all the time, but this type of information would actually lead to those types of reasonable conversations.
And I think, not this one.
You hit that note beautifully, Cynthia.
I think in some of the assignments we get at that. It's like, okay, well, safe is good, but what about cost? What are other factors you can consider? And I'm sorry, I'm drawing a mental blank on which assignments we put those in, but there are some more open-ended questions.
That's fantastic. That's really excellent.
I'm part of a great team. We all work very hard.
Well, as an educator and industry person, I say you guys nailed this. Like, really nailed it. Way to go.
Okay. And I should say this, the assignments are designed to be modular. Okay, so if you had a class where you don't want to have these conversations, take it out. You know, you can do 3 of the 5 questions, 3 of the 7 questions, you can modify this as add your own questions. This is our starting point. There was a question posed by one of the participants saying, can you just drop this into an undergraduate course? Sort of. It depends on your foundations. If you want them to, you know, if you have a group of students who's going to explore and really enjoy this, you can say, here's the directions, go see what you can do, and then come back and discuss. Yes, that could work. But you got to have some foundations with safety at the very least. What is safety? What is a safe chemical? How do we know?
I actually think that this is a wonderful to put this into a seminar type of thing. Especially now we're getting a lot of ethics in chemistry and those types of classes. This type of thing would work beautifully to, you know, get that participation, and that would easily then carry forward into other classes that you're just teaching general subject matter, because again, you're planting the seed for them to start thinking, and that's the key.
We all tried to have a blend of simple look it up questions and some critical thinking questions and some very open-ended questions.
I think this is really great. I really wish that I had something like this back when I was teaching. This is just really, really wonderful.
We did not do this particular exercise. We did the deodorant exercise I am fortunate enough at GGC to have a grant from Beyond Benign to do general chemistry outreach. This was our May event that we gave some background and said, okay, what do you think? You know, what is the hazard band? And we had students using my ChemFORWARD account at the time.
Can I ask a question? So did you use it in your general chemistry course?
I have used this in general chemistry, inorganic chemistry, and environmental toxicology. This particular assignment, we had several assignments in my inorganic chemistry and my environmental chemistry. They were given all of them, and I divided it among the students so we could get the most feedback at the time. But I do plan on using this specific assignment in the fall in general chemistry.
Can I ask, is it first semester or second semester general chemistry?
I have second semester general chemistry.
And which part of the content do you use it around? Like which concept?
I use it in the lab. We have 15 weeks of lab, but we have 3, they're called instructor days, where we can do what we want. I have a theme of green chemistry in my general chemistry course. So I just bring this in for lab safety and, you know, green chemistry and sustainability, and I do it sort of as a lab exercise.
Okay. And I have another question. Do you know if ChemFORWARD platform also has a list of raw materials? Like, is this something that we can use in research to see if, you know, the raw material that we use is safe, or can we get any information about them from ChemFORWARD?
I'm going to turf this to Gabby.
Yeah, I think that there's definitely a research application. There's definitely possible research applications here. If you have an example of a raw material, you can definitely follow up with me, and it's something that we could do like a little pilot on, just even via email. But what we do for a lot of our partners is we take in, even as just like an SDS that they have for a particular material, and we can use that to determine the hazard bands for each of those individual constituents within that particular raw material. And again, that could be really anything. But definitely some research applications there.
Yeah, I'd like to comment on that as well. So I have looked up things we use in my research lab: indole, 3-methyl-indole, tryptophan, all kinds of stuff. Some of it has very complete hazard information, some of it doesn't, right? Just like you would expect. Yeah, it would be useful in research. I have consulted that recently, since that I now have access. So
Thank you.
I don't teach it, but we have an industrial chemistry course here at GGC. I think this would be a great platform, you know, to just show the formulation, what goes into putting it together. I think that would be a great application.
okay, unless there are other questions, what we can do now is, I think what's useful is for everyone to spend more time with the actual platform. So if that sounds fine, if all of you have access and are logged in, we can work through we'll give you a few minutes to work on it on your own, and then we'll compare notes. So one assignment that might be worth looking at is the polar aprotic solvents, if that's of interest, because that's one that could be used in the organic chemistry lab at the undergraduate level, or at any other level for that matter. So let me go ahead and share that assignment. If you have it downloaded and want to pull that up, that's great.
Whilst that is happening, I posted the email and password to help you log in into ChemFORWARD. And so I will put it in the chat again. If you are having any issues logging in, there are many people here who can help you do that. So let's talk about it. It's in the chats right now.
Great. Can everyone see this Word document? Okay, so if you want to take a few minutes and work through this, if you haven't already. So the premise here is the students hypothetically working on process synthesis for scale up of a pharmaceutical. And in one of the synthesis steps, they're looking for a polar protic solvent, which are hard to come by, that are safer. And they'd like to keep the boiling point below 100 degrees because they want to recover that solvent. And if the boiling point's too high, then the energy penalty or the energy cost for distillation is very high in the process. So here are some examples. So if you want, go ahead and look these up, identify the boiling point and the hazard band, and then we'll give you a few minutes and then we'll compare notes. While you're working on that, I'll note that we have provided chem abstract numbers for these as well. You may find it useful to provide the chemical abstract numbers to the students. Some chemicals, there are different entries and sometimes different chemical abstract numbers. So if you provide them the specific chemical abstract number, then there's no confusion there. So I'll give you a few minutes to work on this. If you have any questions, please ask. Okay, can everyone see this?
Mm-hmm.
Okay, so hazard bands off to the right, boiling points in the central column. And you see that a lot of these are F, right? So they're very unsuitable. We have a question mark here, right? So we're not going to want to select that without more information. So if we look at the ones that are the safest, we've got 3 listed as C, hazard band. And of those, acetonitrile has a boiling point of 81. 2-methyl THF is 78, right? So those are in the boiling range we're looking for. But you see that the styrene, which is, very hot solvent right now, and you hear a lot about it, it has a very high boiling point, right? So we would exclude that. Okay. Anyone have any problems finding some of that information?
You have a question mark by DMSO, and I saw a hazard band of B. Was that incorrect?
Oh, well, let's look it up. It could be a mistake.
It has a high boiling point.
Yeah, it definitely has a high boiling
point. So
Sorry, what was the chemical?
DMSO.
DMSO, yeah, we're going to look it up here.
I might have clicked on the wrong thing. I've been known to do that.
Okay, can you see my screen here? This is ChemFORWARD.
Yep.
Yeah. So if we type in dimethyl sulfoxide. Yeah, so we have this one here. Oh, so
Okay.
B. Yeah,
Yeah.
so I think when I looked it up, I thought it was listed as a question mark, so I can correct that.
Okay.
Now, for boiling points, in case you couldn't find it, if you go to properties, boiling points are listed down here.
Yep.
Okay, so easy to find. I'll point out one 2-methyl THF. Maybe one that you talk about in your classes, because this is a very popular solvent being pushed in the pharmaceutical industry because, one, it's biosourced, it's made from corn, it's biodegradable, and it has a better toxicity profile or hazard profile than THF. Okay. So this is also one that's carbon neutral if you were in a country where there's a carbon tax, right? Since it's made from biomass, it's deemed carbon neutral. So this is one that you may already talk about in your courses. And again, you can find in the properties the boiling point. Yeah, 78 degrees.
Some of these solvents too, an interesting thing to look at would be just from an analytical chemistry point of view, right? Because a lot of these solvents are used in HPLC or LCMS. So even though you're not boiling it, you're still going to be getting a fair amount of exposure based on the amount that you're using to perform those tests.
So great. Any questions on this particular assignment? Again, it's just a quick give you a feel. If not, we can turn it over to Cynthia. Was going to, I think, talk about or share with you the botanicals assignment and give you a few minutes to look at that.
If it's okay,
Yes.
I'd like to deviate a little bit.
Sure.
I want to be respectful of people's time. We've got about 15 minutes left. So if I just give you a couple minutes on the idea behind the botanicals assignment, and then we can make sure that you have time to ask questions and we can bring closure to the session, if that's acceptable to the group. Hearing no exceptions. Okay. Again with a screen share. So the botanicals assignment, okay, there is a perception that organic or natural is safe. And to quote Monona Rossell, who is a known industrial hygienist, nature is out to kill you. Okay, so just because it's an essential oil or a botanical extract, that does not mean it's safe. So that is really the purpose behind this particular assignment, to get people talking and thinking about this disconnect, if you will. So these are the components found in a particular essential oil blend. Some of the pieces, it's hazard band C, that's not great, it's not terrible. So those are acceptable, but some of these are unknown. So maybe that's not terrific. Okay, so again, getting your students to look up, the CAS numbers are given. There are chemicals in ChemFORWARD that might have different pieces, so making sure we get the right one. But then we start looking at which are the carcinogens. Okay. Can we make this? Can we improve this by refining it? Well, okay, maybe. These are skin sensitizers. I know lots of people put essential oils on their skin. If it's a skin sensitizer, is that really the best idea ever? Well, I got to tell you, when it treats the rash I have, yes, it is the best idea ever. Look at the SDS for the blend, and in this blend, the ingredients we knew were identified, but most of this blend is unknown. So based on this information, this is sort of the open-ended questions. Do we include biologicals and essential oils in cosmetic products? And that's a great discussion point. Because I know I use them, but doesn't mean they're safe. Okay. So that is really the purpose in this assignment, to emphasize to your students that natural, organic doesn't mean harmless or safe. And okay, I was hoping for 3 minutes. That's close. But I think this is a good point to open it to all of you for questions, whether it's questions about implementation or how to use or where do we find or anything else we've shown you. Try and make sure we get as many of your questions answered as we can. And then we're going to turn it over to Monica, and she's going to tell us about a survey and how to get in contact with us for further questions when you think of more.
So if there are no questions, Cynthia, did you want to comment on implementation, how you implemented the module in the courses you piloted? And I can make a few comments on what I plan to do in the fall.
Sure. I think the biggest thing that I would do, that I did not do in piloting, because we were working on developing the modules and I was spending time in ChemFORWARD working on the modules, I did not sit down with the assignments and do them and play in ChemFORWARD and try to, I'm not going to say master the tool, but learn as much as I could. I think that would be a tip before putting any of these modules into practice. I would give myself about a week to play, pick a chemical you're very familiar with, go play with it and read all you can. When I piloted in the spring, my environmental toxicology course had done a lot with safety and hazards and things like that. I did not use the slides. I gave them the slides that we had and said these were a great reference. I divided the 3 assignments that we had at the time among the students and said, go. As these were all junior and senior students who were public health, environmental science, or biology majors. My inorganic group, we spent some time on safety, but we spent a lot of time on green chemistry. Very similarly, I gave them the slides, I gave them the assignments, I said, go. Ask questions when we need it. They did it as a homework assignment. Everyone did very well. This summer, in general chemistry, we had a lab day. We have some green chemistry, we have some safety. I did like a 20-minute overview, and they did the deodorant assignment, and all they had to do, all I asked them to do was look up the hazard band, look up the specific hazards, and make a suggestion for a replacement. They didn't do all the questions. That's what they did. They were successful. It sparked conversation. Those were the implementations. This fall, I have General Chemistry 2. I have Chemistry for Non-Majors, which is green chemistry, and I have a green chemistry course. I haven't made my plans yet, but ChemFORWARD is on my list for all of these courses. And Arish, I see you have your hand up.
I was just wondering, what was the feedback from the students on using the tool? Like, how did they feel about using the tool? Was it intuitive for them? Did they feel that it was easy? Did they find it useful? You know, that type of thing.
They found it easy to find the hazard band and the hazard. Deciding which substitution they said was a little bit more challenging. I don't think it was the tool. I think it was the chemical knowledge. When I asked, I didn't collect survey data, but they're like, yeah, we didn't have any problems. Monica might be able to speak to that better. I think she's more familiar with the survey results than I am, because I know I looked at them, but I don't recall. I'm sorry.
No, thank you.
Yeah, but we did, as Cynthia said, we did collect data for all the pilot testing we did, and hopefully, like, I could share that with you, Arij, but like the students were like, yeah, I would definitely recommend this to another students and all that, and we hope to collect more from the ones you will be on. Yeah, Mark, do you want to share your game plan?
Yeah, so I had just a few comments. You know, I was thinking about how this might be implemented into organic, which I don't teach. And I think, first of all, the curriculum is so crowded, it would be difficult to cover in lectures. So just like Cynthia mentioned for Gen Chem, I think lab might be the way to go. And if you use a book like the Doxey Hutchison Green Organic Chemistry, there's actually a nice chapter in there on organic solvents and safer organic solvents. And this tool, the platform, would really complement that quite well. It's also an opportunity for students to actually draw the structures and learn what's DMSO and THF and a lot of these common solvents. You can also refer them to safety data sheets to make sure they're looking at SDS. They can get boiling points and information from that as well. And switch this to presenter mode. If you use solvent selection guides, you can use solvent selection guides in conjunction with this platform. So if you're familiar with these, a lot of the pharmaceutical companies have made these publicly available. So this is just one of many from this particular company. And you know, students could go through and compare what is shown here on this particular company's solvent selection guide with respect to polar aprotic solvents compared to what they did on the assignment. And you'll see that there's good correlation. Okay. You can also refer them to the ACS GCI solvent selection guide if you've used that in the past, or if you haven't, you can just go to the ACS website and download this. And again, you can find a correlation. So for instance, if we go down to chlorinated solvents and certain hydrocarbons and aromatics, right, there's some problems. So I think that's a way to incorporate at least that part of the module into organic chemistry. If you're teaching a course on green chemistry, I think it's all potentially useful. And I'm thinking about how I will implement this in the fall, because my course this time will be all distance learning. In the past, it was some in-person lectures, and also some students were distance learning. So now it's going to be all distance learning. So I think what I'll do is early on introduce ChemFORWARD, and then we will use it several times during the semester when we hit certain topics, such as solvents. So anyway, I'll leave it at that, because we're getting short on time. So any other questions that we can answer for you, anything that we can help with in our last 5 minutes? And then I do have actually a slide or two I should share that Monica wanted us to share.
Yeah, while that is happening, I want to say that thank you all for being here. And I know some of you have indicated interest in using it in your classes this fall. ChemFORWARD is providing access to 20 classrooms, and so yes, you are definitely going to get access. And I will reach out with more information about how to reach out to them. And we would like to collect data from what you do in your class. And so like we'll be talking the whole fall, just saying that. So thank you so much for your interest. And we also, Mark, can you share the page with the links? We have 2 links on GCTLC. So for those not familiar with that, this is a new online platform for the green chemistry community. I'm not going to say a lot about it. I'll share more information about this in a follow-up email. And I think we can also share the slides with you, the workshop slides, so that you can get access to all the references and information. But we have 2 GCTLC forum for you to post questions. One is specific to this workshop. And so if you have, as you start with your planning and implementation, Cynthia and Mark will be happy to answer whatever questions or suggestions you have that you would like to share with the green chemistry community. So I do encourage you to use it. And there is a ChemFORWARD module discussion forum. So that is specific to the module. So the other one is if you had any question about the workshop, like maybe how to improve it, how to make it relevant to you, I would definitely want to know there. But if you have ChemFORWARD specific questions, then that forum will be great for that. I'll share more information about this in an email. Next, Mike. Okay, so last thing I say, I just shared an email with you, and I really would love to hear from you what you thought about this workshop. So just a bit of background, this is the first workshop in this series that we started based on how great the work Mark and Cynthia and the ChemFORWARD team did. And I was like, I think one of the things that we've heard a lot about at Beyond Benign is how do we use this resource? There's resource for sure, but like how can I use this in my class? And just attending this workshop, I've heard a lot about how Cynthia has done it and is planning to do it, how Mike is using it. And so I think this is really relevant. And so please share your experience, what you think can make this better, because the plan is to keep doing this as new curriculum materials come out on different green chemistry and toxicology topics. Also, we have, most of you might be familiar with the Green Chemistry Connections. It's a general webinar to learn more about green chemistry. And we have the 2024-2025 schedule ready to roll. The first one will be on September 18th. And I'm pretty sure there will be a lot of information on social media and through our newsletters and so many different places that we advertise. So keep an eye out for that. And that is all I have. Thank you.